Hello, in this video, I'm going to discuss how to connect to Amazon EC2 using Secure Shell or SSH, which is a common method to connect to Linux server. This is part 2 of how do I connect to my EC2 series. I'll start with a quick demonstration, then go through the steps to build the solution. I will conclude with pros and cons of using this SSH solution and discuss several alternatives you may want to consider. So let's jump in. I've opened up a terminal application on my Mac laptop and I will use this SSH command. Looking at this command, we need 3 pieces of information. First is the private key or the PEM file. Next thing is a username, which in my case is EC2-user. The final thing I need is some way to reference my EC2 server. In my case, I'm going to use the public IP address of my EC2 instance. With these 3 pieces of information, I'm ready to connect. If this is your first time using the key pair file, you will get this warning. This message is basically saying that the private key file permission needs to change in such a way that only you as the owner of this file is able to read it. What we need to do is to change the permission so that only you as the owner of this file have read access. So in order to change the permission, we can use this command. Now the private key file is ready to be used to connect using SSH. So let's reissue the SSH command. Now the SSH works. I am connected to my demo public Linux. From here I can issue commands. Here I have a diagram of the solution. I will explain each component and how you can build this for yourself. By the way, if you want to get this diagram and steps to build a solution, see the links in the description of this video. The goal is to launch this Linux EC2 instance and be able to connect from my laptop using SSH over the internet. But before I launch the EC2 instance, I'm going to first configure several networking components to explain the details. So let's go into our console and build a solution. For this demonstration, I'm logged into the AWS console as an IAM user named Stuzio admin. In the IAM user page, you can see that this user has administrator access permission, so I am able to create just about any resource in this account. So the first step is create the virtual private cloud VPC and the subnet. On my console, I'm on the VPC dashboard. I'll click on the Create VPC. I'll use a VPC only option. I'll name my VPC Demo VPC. For the CIDR, I'll enter 10.0.0.0/16. I'll leave everything else as default and click on Create VPC. Before I move on, I'm going to enable the DNS hostname. Notice that currently the DNS hostname is disabled. So I'll go to Action, Edit VPC Settings, check the Enable DNS hostname. If you enable this setting, then your EC2 will get assigned a public DNS name that we can use to reference it from the internet, like a public IP address. Next, I'll create the subnet. Click Create Subnet, and I'll select my VPC. In this case, the demo VPC that I just created. I'll name this subnet Demo Public Subnet. I'll leave the availability zone as no preference because it doesn't matter for this demonstration. For the subnet CIDR block, I'll enter 10.0.0.0/24, which is a subset of the CIDR block of my VPC. I'll leave everything else default and click on Create Subnet. The next step is to create the internet gateway and the route table. The purpose of this component is to create a networking route so I can connect to the EC2 from the public internet. So I'll click on Internet Gateway, Create Internet Gateway. I'll name my gateway Demo Internet Gateway. Notice that the state is currently detached, so I have to attach this to my VPC. I'll go to Attach to VPC and select my Demo VPC and click on Attach Internet Gateway. The next thing I'll create is a route table. Just because we have the internet gateway doesn't mean any traffic will be routed to it. We need a route table that instructs the subnet what traffic should be routed to the internet gateway. So I'll click on Create Route Table, and I'll name this route table Demo Public Route Table. And for VPC again, I will select the Demo VPC. Create Route Table. Notice that the route table has the default route for the local. We need to add a route for the internet gateway. I'll click on Edit Routes, Add Routes. For destination, I'll select 0/0, which is all internet. For target, I'll select Internet Gateway and my Internet Gateway demo Internet Gateway instance. Click on Save Changes. Okay, so now I have two routes on this route table. I now want to associate this route table to my subnet. I'll click on Subnet Association, Edit Subnet Association, click on my demo public subnet. So now I have a route table associated with my subnet that instructs all destinations other than the local VPC CIDR should be routed to the Internet Gateway. The last step before launching my EC2 is to create a security group. Security group is a type of firewall that controls what type of inbound and outbound traffic will be allowed for my EC2. For my use case, I want an inbound rule that allows SSH traffic on port 22 from my laptop's public IP address. So let's go and create this. Back on my console, I'm on the VPC page. I'll click on Security Group. Create Security Group. I'll name this security group Demo SSH Security Group. For VPC, I'll select Demo VPC. For my use case, I don't need any outbound rules, so I'll delete this. And I'll add one inbound rule. For the type, I'll select SSH. Notice when I select this, the protocol and port range is automatically selected for me. For the source, I'll select my IP. This is a public IP address of my laptop. Next, I'll create security group. Now I have a security group with one inbound rule to allow SSH traffic from my laptop. Now that we have all the networking pieces in place, I am now ready to launch the EC2. Back on my EC2 console page, I'll click on Launch Instance. I'll name this instance Demo Public Linux. For operating system, I'll select Amazon Linux and use the Amazon Linux 2023 AMI. For instance type, I'll leave it as T2 Micro. For key pair, I'm going to create a new key pair. This is a public and private key pair that's associated with the EC2. We will need this to authenticate when we connect using SSH. I'll click on Create New Key Pair. Name this key pair Demo EC2 Key Pair. Create Key Pair. Notice when you create this key pair, it gets downloaded to your local machine. Be sure to keep this file securely. For networking, I'll click Edit. For VPC, I'll select Demo VPC. For Subnet, I'll select Demo Public Subnet. For Auto-Assign Public IP, I'm going to enable this. By enabling this, my EC2 will automatically get a public IP address assigned. For Firewall or Security Group, I'll select Existing Security Group, and select my Demo SSH security group that we created earlier. This is all the settings I need. Now I'm ready to launch instance. Let's go check out the instance. It'll take a few minutes to complete the status check. In the instance summary, notice that this EC2 now has a public IP address and public DNS name. Recall that when we created the VPC, we enabled DNS host name. As a result, the public DNS got assigned. We can use either of this information to point to the EC2 from my laptop. Now that we have the EC2 launched and all the networking configured, I'm ready to connect using SSH. I've opened up a terminal application on my Mac laptop and I will use this SSH command. Looking at this command, we need three pieces of information. First is the private key or the PEM file. I have this file downloaded on my laptop and I've navigated to the directory where this file exists. In my case, the downloads directory. If you're issuing this command from another directory, you can pass in a path to the file. Next thing is a username, which in my case is EC2-user. In order to get this value, you can look up the default username in the EC2 documentation. For my Amazon machine image, the default username is EC2-user. The final thing I need is some way to reference my EC2 server. In my case, I'm going to use the public IP address of my EC2 instance. I can get this from the EC2 console and see the public IPv4 address, or optionally, the public DNS. With these three pieces of information, I'm ready to connect. If this is your first time using the key pair file, you will get this warning. This message is basically saying that the private key file permission needs to change in such a way that only you as the owner of this file is able to read it. If I look at this file, you can see here that the first three characters are for the owner permission, which is read and write. Then the next three characters represents the group, which in this case is read access, and for all others, read access. What we need to do is to change the permission so that only you as the owner of this file have read access. So in order to change the permission, we can use this command. What this command is saying is to change the permission of the PEM file to be read-only for the owner user. The 400 may seem mysterious, but this is a shortcut way of saying the first digit 4 is for the read permission for the owner, 0 is for no permission for members of the group, and final 0 means no permission for all others. After this command, let's look at the details of this file again. Now you can see the difference in the permission for this file, which says that the owner has read access and all others have no permission. Now the private key file is ready to be used to connect using SSH. So let's reissue the SSH command. Now the SSH works. I am connected to my demo public Linux. From here I can issue commands. And when I'm done, I can type exit. You can see that using SSH with private key file is fairly straightforward. However, this option has some drawbacks. First, you need the private key file to connect. This may not be a big deal if you're working alone or in a small team, but imagine if you have thousands of servers with hundreds of people who need to connect. Now you need to distribute potentially thousands of private key files to hundreds of people. This can quickly get out of hand as people come and go and new EC2 servers are spun up and terminated. Another issue is that anyone with the private key file can connect and doesn't require any AWS IAM authentication. So if these files got out, it represents a serious security risk. Finally, the EC2 needs SSH port 22 open for connection, which is another potential security concern. So while SSH Client Connection is simple, it may not be the best option for large organizations that require more scalable and secure solutions to connect. This is where you may consider options like EC2 Instance Connect or Session Manager. You can see here some of these solutions don't even require public IP or RDP port to be open or even need a private key file. You can learn more about these other SSH solutions in the video links in the show notes. Well, I hope you found this video useful. Thanks for watching and keep on building.